Hello guys, welcome to Matro. Today I'm going to give you tips on how to get GCF and LCM. Let's have a review. GCF is greatest common factor, while LCM is least common multiple. GCF is the greatest number that can exactly divide two or more given numbers, while LCM is the least number that can be divided by two or more given numbers. GCF is used when reducing fractions in simplest form, while LCM is used when changing dissimilar fractions into similar fractions. They can be called as GCD or greatest common divisor when used to simplify fractions, or LCD or least common denominator when changing dissimilar fractions into similar fractions. Both of them are used to solve real-life problems. The common methods used to solve for GCF and LCM are listing method and continuous division method. And in this video, we're gonna focus on continuous division method. Did you know that with this procedure or method, we can actually get both GCF and LCM? Here how it goes. Suppose we want to get the LCM and the GCF of 24 and 18. So first, we proceed to our continuous division method to get the GCF. Dividing 24 and 18 by their common factor, which is 3, we'll get 8 and 6. Then, dividing them again by 2, we'll get 4 and 3. And since there's no more number that can divide 4 and 3, then we can already get our GCF, which is the product of the two common factors that we use. So we have the GCF of 24 and 18 is 6. To get the LCM, right, you can actually get the product of these two numbers, the diagonals. You multiply 24 times 3 and you'll get 72. Or you can opt to get the product of these other two numbers, 18 and 4, which when multiplied will also give us an answer of 72. Let's have another example. Find the GCF of 45 and 30, as well as its LCM. So we divide 45 and 30 by 5, we'll get 9 and 6. Dividing 9 and 6 by 3, we'll get 3 and 2. And since 3 and 2 are relatively prime, we can now get our GCF. So we have 5 times 3, the GCF is 15. So for LCM, we can again get the product of these two diagonal numbers. 45 times 2 will give you 90. So that's the LCM. Or you can get the product of 30 and 3, which will also give us the same product as 90. Okay, but did you know that without computations, you can actually get the GCF and LCM of two numbers? Let's take this for example. Find the GCF and LCM of 7 and 28. Notice that one number is a factor of the other. 7 is a factor of 28. In that case, the GCF is 7, while the LCM is 28. So, if one number is the factor of the other number, the smaller number is your GCF, and the bigger number is your LCM. So you don't need any solution at all. Let's have another example. Find the GCF and LCM of 45 and 9. So as you see, 9 is a factor of 45. So one number is a factor of the other. So the GCF will be 9 and the LCM will be 45. Here's another example. 12 and 60. 12 is a factor of 60 because 12 times 5 will give you 60. So since one number is a factor of the other, then the GCF is 12 and the LCM is 60. Sometimes you just need to observe the given. So if you see that one number is the factor of the other, then you don't need any solution at all. Okay? Let's have this. Find the LCM of 7 and 9. When the numbers are relatively prime, meaning the only number that can divide them is 1, so their GCF is 1, their LCM will be their product. So the LCM is 63. Let's have another example. 8 and 5 are relatively prime. So that means their GCF is 1. So their LCM will be their product. So 8 times 5, the LCM is 40. Alright, let's take this for example. 5 and 12. They have no common factor except 1. So that means that their LCM will be their product. So 5 times 12, the LCM is 60.